Get ready, because one of the Pacific Ocean's most active volcanoes might blow any minute now. Scientists monitoring axial seamount, a gigantic underwater lava factory just off the coast of Oregon, say it could erupt literally any time between today and early 2026 at the latest. Yes, it's underwater, but don't get tricked by the ocean's cover. This beast is almost 3 times taller than the Empire State Building. This volcano is inflating like a souffle at a Michelin-starred restaurant, and scientists are so excited they will live stream it. Seriously! So here's the thing. This volcano will explode at any moment now because, well, it's inflating fast. Over the past few months, researchers have noticed that the seafloor is literally rising. It's like Axial is doing its best impression of a waterbed filled with molten rock. Scientists call this inflation, which sounds like something you'd complain about after Thanksgiving dinner. But in volcano terms, it means magma is piling up underground, causing the seafloor to bulge like a souffle that's this close to collapsing. Now, an underwater volcanic eruption might not sound so exotic. After all, most volcanic activity on Earth happens under the sea. Believe it or not, there are more than 1 million submarine volcanoes quietly churning lava beneath the waves as you watch this. The ocean floor is Earth's biggest volcanic hotspot. What makes axial seamount so thrilling is that it's under intense scientific surveillance, unlike any other underwater volcano. It's like the star player in a volcanic reality show, with a network of ocean-bottom instruments giving researchers real-time updates on magma movements, seismic tremors, and crust deformation. In fact, axial seamount hosts the world's first-ever underwater volcanic laboratory. Scientists have been keeping a constant eye on it since the 1990s, when they installed sensors that now relay live data straight from the seafloor. This kind of monitoring is unheard of elsewhere and has turned Axial into a geological celebrity, one whose behavior we can track with remarkable precision. Besides, Axial is hilariously predictable. It erupts roughly every decade, and right on cue, it's gearing up for another performance. By mid-2024, it had inflated to nearly the same level as before its last eruption, which means the countdown is on. Scientists are so confident in its schedule that they've set up a volcanic advent calendar, waiting for the day when Axial decides to pop. But hold on, axial seamount isn't just your average underwater volcano. It's got style, personality, and a geological identity of its own. Now, most underwater volcanoes, called seamounts, tend to look like cones or flattened domes. Axial laughs in the face of tradition with its unfashionably rectangular caldera, a 2-by-5-mile crater that looks like it was designed by a geologist with a ruler and a grudge against curves. Most volcanoes opt for the classic circular look, but Axial, it went full avant-garde. This caldera is punctuated by fissures, vents, lava channels, and mysterious dome-like structures that rise hundreds of feet high. It's like the volcano's wearing a funky geometrical crown instead of the usual rounded hat. What's more, Axial's location is like prime real estate for geological fireworks. It sits right where 2 major forces collide, literally. First, it's on the Juan de Fuca Ridge, an underwater mountain range formed where 2 tectonic plates are slowly pulling apart, like a zipper being undone. Second, it's perched atop the Cobb Hotspot, a deep mantle plume that acts like Earth's sneaky magma espresso machine, pumping molten rock from deep inside the planet and fueling a whole chain of seamounts. To put it plainly, it's like the tectonic plates are reluctant dance partners, sliding away from each other, while the Cobb Hotspot acts as the DJ, turning up the heat and keeping the magma party going. This dual influence creates a complex plumbing system inside the volcano, with magma chambers filling, draining, and shifting in ways scientists are still trying to decode. The competition between the spreading plates and upwelling magma is what gives Axial its unique geological fingerprint, and it's also why this volcano keeps surprising us. Now, we said that Axial Summit isn't just a crater. The truth is that inside, the action gets even weirder and cooler, well, hotter, but you get it. Axial hosts black smoker hydrothermal vents, which blast superheated water at temperatures exceeding 700 degrees Fahrenheit. This is no ordinary underwater hot tub. These vents create one of Earth's most extreme environments, where bizarre creatures thrive in total darkness and scalding heat. Giant tube worms, crabs, colonies of bacteria, and even octopuses live off the mineral-rich plumes that gush from these vents, forming ecosystems completely independent from sunlight and photosynthesis. It's like an alien world beneath the waves, thriving off the volcano's fiery breath. These vent communities are crucial to science, not just because they're strange, but because they may resemble the earliest ecosystems on Earth. Some researchers believe life on our planet may have originated in similar deep-sea hydrothermal environments billions of years ago. Studying them could also help us search for life on icy moons, like Europa and Enceladus, where similar vents might exist beneath their frozen surfaces. When axial erupts, it's like a natural reset button for these communities. The lava wipes everything out, but within months, life comes roaring back. Proof that even in the most hostile environments, real estate is always in demand. For those worrying about tsunamis or coastal disasters, relax. Axial eruptions are the underwater equivalent of a slow cooker. The immense water pressure keeps things chill, well, scalding, but not explosive. So the worst thing that happens is some lava decorates the seafloor, and a few crabs have to find new vents to squat in. This means no massive ash clouds or explosive blasts that could reach the surface. Instead, lava oozes out and spreads across the seafloor, sometimes traveling for miles. But for scientists, this eruption is the golden ticket. Understanding axial patterns could help predict eruptions elsewhere, even on land. Plus, its bizarre ecosystems offer clues about how life might survive on other planets. Not bad for a volcano that mostly just sits around looking rectangular. Still, the volcano's activity can be heard in the form of thousands of small earthquakes every day. Thousands! As if the volcano itself was groaning and creaking, preparing to burst open. Again, we won't feel a thing, but at least they'll help scientists track the magma's movements and the volcano's eruptive cycle. Now, one of the coolest parts of this story is that scientists are preparing to live-stream Axial's next eruption for the first time ever. Imagine watching an undersea volcano in action, live, as it's painting the ocean floor with fresh lava. It's like a front-row seat to a natural fireworks display, thousands of feet beneath the waves. The livestream will come courtesy of the Ocean Observatory's initiative, which maintains a series of fiber optic cables linking Axial's instruments directly to shore. It's the Wi-Fi of the deep sea, and it's about to broadcast molten rock in HD. And there's another twist. Scientists have noticed a curious pattern in Axial's eruptions. All three of its most recent eruptions, in 1998, 2011, and 2015, happened between January and April, the months when Earth starts moving away from the Sun. So why? Well, it might have something to do with the Moon's gravitational pull. The Moon's orbit causes ocean tides to rise and fall, which changes the pressure on the seafloor and could help nudge the magma chamber to its breaking point. I guess the Moon isn't just a romantic light in the night sky. It might be the ultimate volcanic whisperer. So, one thing's for sure, when Axial goes, it'll be the best documented underwater eruption in history. So, keep your eyes peeled. This is one natural spectacle you won't want to miss. And who knows, if we're lucky, we might even get deep-sea eruption ASMR out of the deal. Now, if you'll excuse me, I'll be refreshing the live feed like it's a Taylor Swift ticket sale. If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes, like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater. a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these two being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger.
7,500 years ago, the Pacific floor collapsed. Massive landslides buried the seabed in seconds. Fast forward to today, robot subs have examined the place. Scans have revealed proof of at least 10 distinct cyclical megaquakes. Now, researchers warn, the plates are still locked and building pressure, even today. If they start moving, that could trigger new red alert earthquakes and send disastrous tsunamis toward the coast. Let's look at the map. The fault here is like a giant zipper. It's over 600 miles, stretching from northern California to Canada. It's called the Cascadia Subduction Zone, and it's a part of the Ring of Fire. You know, the famous giant horseshoe around the Pacific that can serve as your where-to-go reminder if you're into volcanic and earthquake tourism. One of Cascadia's biggest events happened around the year 1700. There are no local written records of it, but there is a story. A well-known indigenous legend tells of an epic battle between a thunderbird and a whale. In the story, the thunderbird's wing beats make the ground shake. The whale's thrashing sends seawater flooding inland. The thunderbird wins by finally grabbing the whale and slamming it back down, shaking the land itself. Many researchers believe that this legend originated from the real earthquake of 1700. But we don't just have cool myths to give us the full picture. In the early 1700s, samurai officials recorded waves flooding villages and rice fields, but nobody felt the earthquake that must come first. That's why they nicknamed this event the Orphan Tsunami. But it did have a parent, and it took scientists 300 years to finally connect it back to Cascadia. To see Cascadia's past, researchers sent robot subs to scan the bottom in crazy detail. They expected to see a simple crack, but what they found looked more like giant underwater steps. Some of those steps are about 33 feet tall, like a 3-story building. That only happens when a big piece of the seafloor snaps off, breaks loose, and slides all at once, not slowly. When that happens, it kicks up a mud avalanche. Picture a jar of dirt and water. Shake it hard, and a fresh layer settles at the bottom. Each layer is basically a timestamp from a huge quake. When scientists counted and dated them, they found 10 separate megaquakes that hit one after the other over thousands of years. That means that Cascadia doesn't let pressure out little by little. It stays stuck for a long time, then suddenly breaks out violently. That pattern is why the Cascadia subduction zone is considered one of the scariest fault systems in North America today. So what's actually happening down there? The plates aren't sliding smoothly, they're stuck. And while they're stuck, the coastline is getting quietly bent out of shape like a ruler you're flexing in your hands. It doesn't look dramatic day to day, but it's been loading up for centuries. When that tension finally snaps, the coast will instantly drop. Geologists call this co-seismic subsidence. We're talking about the ground plunging 6 to 8 feet vertically in a matter of minutes. Imagine standing on a beach. The shaking stops, and you realize the ocean is rushing in. Not just because of a wave, but because the land you're standing on has physically sunk below sea level. That one move is enough to shove the seafloor out of position and force the ocean above it to react. Cascadia can produce a magnitude 9.0. That's top tier, categorized as the most destructive natural event that can happen. It can shake the ground for minutes, pushing and pulling everything back and forth until buildings and bridges start falling down. A 9.0 class quake also means the seafloor is vibrating and shifting, lifting in some spots, dropping in others, all in one sudden motion. A tsunami starts when the seafloor moves and pushes a huge amount of water out of the way. If the bottom suddenly lifts or drops, the water above it gets displaced instantly. That water has to go somewhere, so it races outward in every direction. Out in deep water, that wave is rarely tall. It spreads out across a long distance, so it can pass under ships without anyone noticing. The danger is speed. In the open ocean, tsunamis can travel around 500 to 600 miles per hour. That's like traveling from New York to Detroit in 60 minutes. Eventually, the ocean starts to pile up, getting taller by the second. Near shore, it can stack up to tens of feet, and in extreme cases, it can run up to 100 feet on land. It swallows the coast, then drags everything back to sea with a violent tug before the next hit arrives. But that's not all. When the fault snaps, it often triggers massive underwater landslides. When a huge chunk of seafloor collapses, it can shove water locally, like dropping a boulder into a tub. In the Cascadia subduction zone, you aren't just dealing with the earthquake's kick. You're getting a 1-2 punch from the shifting crust and the crumbling slopes combined. On parts of the Oregon coast, emergency experts say the shaking could last 5 to 7 minutes, long enough to realize what's happening and still won't be over. Then comes the scariest part. In some places, a tsunami can hit in 15 to 30 minutes. Remember, the earthquake is a warning. If you're on the coast and you feel strong, long shaking, you do not need to wait for a text alert or a siren, or someone on the news to yell tsunami. During the tremors, the basic recommendation is to literally drop to the ground, cover, and hold on, staying away from windows and chandeliers that can fall on you. As tempting as it is, we shouldn't stop to make a reel out of the situation. Before anything happens, make one decision while your brain is calm. Pick the closest high ground and go for it. Not somewhere uphill, an actual spot. If you ever needed a reason to learn your neighborhood, this is it. Your instinct might say, get into the car and drive. But don't. Roads are probably jammed and bridges could be damaged. People who live on the coast already know to keep it practical, with shoes on the bed and a go bag prepared just in case. The danger doesn't end with the first impact because the tsunami waves, well, they come in waves. The initial hit is rarely the largest, and the ocean can continue to pulse in and out for hours. This creates a violent tug-of-war. The receding water acts like a massive vacuum, dragging anything caught in the backwash out to sea. Japan's 2011 disaster is the most recent vivid example of what a magnitude 9.1 can do. The seafloor shifted in a single massive heave, and minutes later, the ocean literally rearranged the coast. A huge wall of water crashed inland, reaching over 100 feet high in some spots, and turning the coastline into a conveyor belt of debris. It was like water turned cars into giant bowling balls and shipping containers into massive metal bricks, smashing ports and drowning low-lying airports and electrical substations. Finally, what do officials say about the timeline for the possible next disaster hitting Cascadia? Well, they can't give us precise dates, but they did announce some odds. For the biggest, scariest earthquake possible, the United States Geological Survey says there is about a 10% to 15% chance it'll happen in the next 50 years. Chances for a quake that isn't the mega version are 1 in 3 in the next 5 decades. Those odds are actually pretty high. But here is why it isn't all that grim. Scientists know this isn't random. Cascadia has a pattern, and patterns are what preparation runs on. We already know how to build for big shaking, and we're getting better at spotting where stress is building. It doesn't mean we can stop the earthquake, but it means we're getting way better at knowing what to expect. In the meantime, just keep a go bag by the door and maybe take a walk around your neighborhood every once in a while.
In 2015, a volcano erupted, and the seafloor dropped about 8 feet, like an elevator giving up mid-ride. By then, scientists had already put wires and sensors all over the place. The idea here was simple. Since it erupted fairly often, they wanted to predict the next disaster. And they sorta did. They circled 2025 in red and waited. Except nothing happened. But the ground is still swelling and quaking almost daily. And now everyone is worried. Let's see why. Axial Seamount is a volcano about 300 miles off the Oregon coast. But to really find it, you would need to dive almost a full mile. You'll also find something unexpected there – yellow cables, miles of them. This is one of the most watched volcanoes on the planet. Through a massive project called the Ocean Observatories Initiative, or OOI, scientists draped the underwater mountain in 550 miles of fiber optic cable. Sadly, it's an observatory in name only, serving more as a science experiment than a proper observatory. There's no cool-looking dome where people live and research underwater. These cables power a massive network of sensors. They count earthquakes, track the ground rising by fractions of an inch, and listen to the magma rumble. These sensors are so sensitive that they can feel the moon. When the tides rise, the extra water presses down on the volcano and sets off tiny earthquakes. To put this all in place, they had to use remote-controlled robots that dove down and physically plugged those sensors into the network. Plugging a TV into an extension cable in a dark room is hard. Now imagine doing that 4,600 feet under the surface. You're using a robot arm, and the pressure is strong enough to crush a small pickup truck. But why go through all this trouble? Volcanoes are lazy. Most sleep for centuries. Some wake up once, flood half a continent with ash, and then go quiet for hundreds of millions of years. If you study volcanoes, you might wait your entire career and never see a single drop of lava. But Axial sits right where two tectonic plates are ripping apart. Magma is constantly refueling the tank. It's not the type that needs to wait hundreds of years to recharge. It can erupt every decade or so. Now, it doesn't blow its top like Mount St. Helens. There's no earth-shattering kaboom. Instead, the ground swells up, cracks open, and lava pours out quietly to create new rock. When the floor cracks, it blasts out a massive cloud of superheated water called megaplume that's packed with subsurface bacteria. It rises thousands of feet high and looks like a blizzard of white snow shooting through the dark ocean. Each eruption basically resets the biome, forcing life in the area to start over. That combination, frequent and calm, makes it perfect for study. It erupts often enough that we can actually collect data, and is predictable enough that we can build a model around it. By 2014, the observatory had already been in place, just in time for the eruption that happened in 2015. Scientists caught the whole event live. They had sensors on the seafloor that showed the ground puffing up like a giant balloon as melted rock gathered underneath. The ground rose up several feet until the pressure made the rock start to crack. This caused thousands of tiny earthquakes in just one afternoon. Then, miles-long cracks ripped open and lava poured out. As that magma leaked out, the ground lost its support. Eventually, the seafloor inside the volcano's crater collapsed. The whole point of capturing 2015 was to build a baseline. This is what right before an eruption looks like. So when the crater floor started rising again and the quake counts climbed, scientists figured Axial was heading toward another eruption in 2025. And then, nothing. Nada. Zippo. The signals reached the same zone that worked last time, but there was no eruption. It's like pumping air into a tire until it should blow, and it doesn't. So what went wrong for the researchers expecting a quiet explosion? What likely happened is that the volcano stalled. In 2015, the ground rose quickly, but nature likely changed the tempo. Magma is still filling the chamber, but it's pumping in slower than it did 10 years ago. It's also possible that the rock is stronger now, holding cracks better, forcing the volcano to swell even more. Now, there's also a third option, a quiet leak. Tiny fractures could be hissing out just enough pressure to delay the main event, keeping the volcano in a state of suspended animation, ready to blow but lacking the spark. And even with all the data, it's still hard to tell the difference between almost ready and about to break. That's why the forecast slid from 2025 to mid to late 2026. The volcano stayed active, but the buildup slowed, pushing the breaking point back by about a year. But why is this making scientists nervous? When you hear about the consequences of eruptions, it's easy to imagine a tsunami heading for the coast. Well, it's not. You can keep your surfboard in the garage. This is a deep ocean event. The water absorbs almost all the energy. The surface might get a little bubbly, but nobody on the beach is going to spill their drink. The people sweating are the ones who paid for the robots. The problem is that the lab is sitting inside a test tube. Remember, the volcano is currently overcharged. It has already swelled past the point where it usually pops. If it waits until late 2026 to finally let go, it could have accumulated significantly more magma than it did in 2015. A bigger eruption means new, cool data, but it also means a much larger volume of lava. Those expensive yellow cables and delicate sensors, they're sitting right in the splash zone. If the lava follows the old paths, the gear is fine. But an overpressurized release could rip open new cracks in the seafloor. If that happens, researchers could lose millions of dollars of equipment in seconds. Scientists might be watching the feed live, see a wall of molten glass, and then static. But the real worry isn't the money. Axial is supposed to be the gold standard. It's the most monitored square mile of the ocean floor on Earth. It was supposed to be the easy one. If our prediction model fails here, well, it's a bad sign. We have every sensor imaginable, and we still don't understand underwater volcanoes as well as we thought. If we can't predict the friendly volcano when it's wired for sound, what chance do we have with the dangerous ones? The vents around the volcano pump out water that could reach around 650 degrees Fahrenheit. On the surface, that would instantly turn to steam. Down here, the pressure is so intense that the water can't boil. But it's so hot it can dissolve minerals. The place is also loud. If you could hear it, it would sound like a jet engine on a runway. Plus, the area is carpeted in tube worms. They look like giant 6-foot-tall white pipes with bright red tips. They don't make biological sense. They have no eyes, no mouths, and no stomachs. They don't eat food at all. Instead, they host bacteria inside their bodies that turn the volcano's toxic sulfur gas into sugar. They're basically powered by pollution. Crawling all over them are scale worms. These things look like they belong on some other planet. They're covered in microscopic scales that refract light. So if you shine a flashlight on them, you could see them sparkle in blue and red. The ground beneath them is also strange. When axial erupts, the lava hits the freezing seawater and cools instantly. But it doesn't turn to gray stone. It turns into glass. Pure black obsidian. If you tried to walk on it, it would sound like you were walking on thousands of light bulbs. Experts have updated the schedule for this year. Cameras are in place to take some cool pictures, and we might even get a live stream on YouTube, watching the ground tearing open under the ocean. Let's just hope that it isn't the final broadcast. It's really hard to stream the next one if your multi-million-dollar camera ends up digested by a river of molten glass. I'll say.
Yellowstone is the internet's favorite doomsday volcano. Maybe you heard the prediction. One super eruption, then a continent dusted in ash and temperatures going down. A perfect disaster movie scenario. Yet, geologists worry about a different kind of volcano. One that won't explode only once. It could rip the ground open, flood the entire continent with lava, and make the air unbreathable. And we know this because it happened before. Right now, researchers think there might be around 20 supervolcanoes scattered across the planet. Short story, we fear those. Long story, a major supervolcanic eruption could collapse modern society as we know it. A normal volcano can cause a local disaster. It can wipe out a city and turn a region into a no-travel zone. When Mount St. Helens exploded in 1980, it was huge. The eruption blew the top off a mountain and flattened forests like knocking down dominoes. It showed the world just how scary volcanoes can be. But in geological terms, it's nowhere near what a supervolcano could do. Mount St. Helens threw out roughly a third of a cubic mile of ash, enough to make a football field pile about 150 miles high. For comparison, a supervolcano could bury the entire state of Texas 5 feet deep, and Texas stretches about 800 miles. Volcanoes like St. Helens are mountains that build up over time, layer after layer, like nature stacking spilled wax. They erupt, they cool, they erupt again, and you end up with a cone that looks cool in photos. A supervolcano is like a hidden pit. It resembles a giant underground tank of molten rock covered in a thick slab of crust. Imagine the magma chamber like a huge underground room, and the ground above it is the ceiling. During a super eruption, cracks rip open across that ground and magma forces its way up through them, like steam blasting out of a pressure cooker. Ash and gas roar high into the sky. It can start in multiple spots across a wide area, not one neat hole. The magma chamber underneath can empty so violently that the roof above it collapses, the land drops, and what's left is a massive bowl-shaped scar called a caldera. And Yellowstone is the prime example. About 631,000 years ago, Yellowstone had a massive eruption and it left behind a giant caldera about 30 by 45 miles across. Now it's a national park, but it's also basically a footprint, like a warning. If Yellowstone erupted again, the first super hot clouds of ash and gas could blast outward and burn everything nearby. Then the ash would spread. And ash is not like the fireplace dust. It hurts to breathe. It wrecks engines, and it can shut down flights and machines. Regular volcanoes mostly hit the area around them with lava. A super eruption turns the air itself into a real danger. Ash spreads far and jams the things we depend on. High up, sulfur can turn into a thin haze that will block some sunlight. That can cool things for a while and mess with growing seasons, even far from the eruption. And winds can spread that effect well beyond the US. However, geologists worry about something even worse. A kind of eruption that can keep going in waves and cover huge regions in lava. It's called a large igneous province. It's not one volcano, it's a whole stretch of crust that starts leaking lava through long cracks over and over for a long time. Instead of one giant explosion, it's more like Earth turning on a lava faucet that just keeps going. Imagine a crack in the ground hundreds of miles long. Out of that crack comes a sea of lava, but this isn't the sticky, slow stuff you see in Hawaii. This is hot, runny, fast-moving lava, and it doesn't stop. It spreads, floods low spots, stacks into layers, and then does it again. And that's what makes LIPs scarier than a supervolcano. They drag on. They can erupt in repeated pulses over hundreds of thousands to a few million years. We have scars to prove it right here in the US. About 17 million years ago, the Pacific Northwest ripped open and created the Columbia River basalt. Lava did not just coat the land, it drowned it. The total amount that erupted was around 42,000 cubic miles. That's enough to cover the whole US in lava about 58 feet deep. But how can Earth produce enough lava to bury a mountain range? It's because the planet is still churning inside. Imagine Earth like a pot of thick tomato soup sitting on a stove. Earth's core is the stove, and it's extremely hot. The soup is the mantle, a thick layer of rock that moves slowly. Now and then, a massive blob of superheated rock rises from deep in the mantle, possibly from the boundary above the core. Scientists call this a mantle plume. When it reaches the cooler crust, it spreads out, pushes upward, and when it breaks through, it does not build one neat mountain. It can open long cracks and feed eruptions in repeated bursts for a very long time. However, while lava burns everything in its way, it's not what wrecks the planet. The gas does. These eruptions release huge amounts of carbon dioxide and sulfur, and we can assume the consequences of that because it happened before, and not just once. About 252 million years ago, a massive LIP eruption began in what is now Siberia. It lines up with the worst extinction event in Earth's history, the Great Dying. Around 90% of species disappeared. Huge amounts of gas flooded the air and trapped heat. The ocean soaked up some of that gas and turned more acidic. Acid rain fell again and again. Life on Earth crashed. Scientists believe that in the last 500 million years, there have been 16 major extinctions like this, and that 15 of them line up closely with LIP timing. These geological formations changed Earth so many times, and scientists now wonder, what if Yellowstone and that massive lava flood in Oregon are actually a part of the same system? Look at Idaho from space, and you see a long, flat track across the state called the Snake River Plain. It points from the old lava flood region toward Yellowstone, like a trail. That path exists because Earth's surface moves. The outer layer is split into giant plates that slowly slide. Under Idaho and Yellowstone, a deep, hot zone keeps feeding eruptions. As the plate moves, the eruption zone shifts with it, leaving a long trail behind. That's why the rocks get older the farther you go from Yellowstone. It's the same heat source, just a moving target. And if you roll the plate's motion back far enough, that trail points closer to where the Columbia River basalts formed. That's why some geologists think the Northwest lava flood and Yellowstone could be connected parts of one long-lived system. Finally, if it's all part of one big apocalyptic system, is it time to pack the bags and flee to Mars? Will it happen again soon? Even if they share the same story, that does not mean the worst part is coming back soon. The lava flood chapter played out millions of years ago. Today, Yellowstone is simply where that deep heat shows up at the moment. And sure, it can erupt again, but the most likely eruption isn't some giant doomsday blast. It's a steam explosion, when super hot water flashes into steam and blows rock apart. Lava flows and smaller eruptions can happen too. The caldera-making nightmare is a rare one. If Yellowstone ever started building towards something big, it wouldn't be sneaky. You would see it coming. A lot more earthquakes than normal and the ground lifting faster than usual. The clearest right before signs would likely show up in the days or weeks before it. We cannot stop a planet-scale eruption. We can only watch for the warning signs and plan. But hopefully, if the planet decides to get rid of us, by the time it starts sending warnings, we'll already finish turning Mars into our new home. There's an old volcano in Bolivia called Uturuncu. It hasn't erupted in about 250,000 years, so you may think that's the end of its story. But recently, it has started to act a little strangely. At the moment, it resembles a zombie that's waking up from a long nap. Uh-oh, is that kind of apocalypse nearing? Uturuncu is a huge mountain in the Andes that's almost 20,000 feet tall. It's called a stratovolcano, which means it's big, steep, and cone-shaped. These kinds of volcanoes are made from layers of lava, ash, and rocks. They can have terrifying, powerful, explosive eruptions because their lava is thick and traps gas inside. Think of it like a shaken-up soda that's ready to burst. Famous ones like Mount Vesuvius are just like Uturuncu. And do you remember about the tragic fate of Pompeii, completely destroyed during the eruption of Mount Vesuvius? Does something similar await Bolivia? Even though Uturuncu has been quiet for a long time, scientists have noticed that it's been letting out gas, rumbling with small earthquakes, and even making the ground around it bulge, kind of like it's stretching. So, people started wondering if it was getting ready to erupt again. Scientists decided to take a closer look at this situation and found out that liquid and gas moving around under the volcano is causing all this activity. It doesn't mean the volcano is definitely going to erupt, but it helps explain why it still seems alive. Let's dive into details. Since the 1990s, scientists have been using satellites and GPS to keep an eye on the ground around the Uturuncu volcano. At one point, they noticed something weird. The ground was rising in the middle and sinking around the edges, kind of like a sombrero hat. The middle part has been slowly going up for at least 50 years, by about 0.4 inches a year. It doesn't sound like a lot, but hold on. This strange shape, along with lots of tiny earthquakes and gas like carbon dioxide coming out of the volcano, made scientists think that there might be a giant blob of magma growing under the mountain. If that were true, it could mean only one scary thing. The volcano could be getting ready to erupt. Uturuncu sits on top of a huge underground pool of magma called the Altiplano Puna magma body. This pool is really big and really deep, stretching under parts of Bolivia, Chile, and Argentina. Scientists thought that magma from the APMB might be rising and collecting near the surface, which could lead to an eruption. But now, after studying more than 1,700 earthquakes and checking the rocks around the volcano, scientists have a new idea. Apparently, it's not magma rising up. Instead, hot fluids and gases are traveling up from the APMB through a narrow path shaped like a chimney. These gases, like steam and CO2, can get trapped under the top of the volcano, while salty water, brine, spreads out sideways into tiny cracks in the rocks. This moving gas and water can make the ground rise and fall and cause small quakes, without any magma getting close to the surface. So the good news is, Uturuncu probably isn't about to erupt. If it did happen, it would cause serious damage to nearby communities and even pose a threat to human lives. Lava flows could reach towns tens of miles away from the volcano, and volcanic ash could even spread across Bolivia, Argentina, and Chile. Luckily, even though the volcano is still alive and rumbling, it's not as dangerous as scientists once thought. This discovery might help scientists figure out if other volcanoes around the world are getting ready to erupt. Now, let's visit Alaska, where according to researchers, Mount Spur might erupt soon. It's letting out strange amounts of volcanic gases from the top and side vent, the very vent that last erupted in 1992. If it erupts again, it could cause problems for airplanes flying nearby and might send ash falling from the sky. The good news is that nobody lives close to it, so people are safe for now. But even though Mount Spur isn't super dangerous, there are other volcanoes around the world that could be really destructive. One of those is Campi Flegrei, a giant volcano system near the city of Naples. Instead of one big mountain, it has 24 craters spread across the area. It last erupted in 1538, but its biggest eruption happened about 40,000 years ago. That explosion covered the whole Mediterranean region in ash and made temperatures drop by up to 16.2 degrees Fahrenheit in Eastern Europe, which led to a very cold volcanic winter. If Campi Flegrei erupted again today, it could be very dangerous. It might cover Naples and nearby places in ash, causing earthquakes and landslides, and create air pollution and acid rain. Scientists are keeping an eye on it, especially after a 4.4 magnitude earthquake shook the area in March 2025. But the good news is there's no sign that magma is rising to the surface right now, which means an eruption isn't expected soon. Still, since Italy has a lot of volcanic activity, experts continue to watch it carefully. Mount Vesuvius is also in Italy and is one of the most famous volcanoes in the world. It's known for its huge eruption in 79 CE that buried the Roman cities of Pompeii and Herculaneum. The last time the volcano erupted was in 1944. Today, Vesuvius is even more dangerous because over 3 million people live near it. Around 700,000 people are living illegally right on its slopes, which puts them even more at risk. If the volcano erupts again, it could send rocks and ash flying through the air at nearly 100 miles per hour and cause major destruction, possibly even wiping out Naples. And still, scientists believe a big eruption from Vesuvius probably won't happen for a few hundred more years. But since it's still an active volcano, researchers continue to monitor it. Cumbre Vieja is a volcano on the island of La Palma, which is part of the Canary Islands. It last erupted in 2021. During that eruption, lava poured out of the volcano and flowed all the way to the sea. It destroyed over 3,000 homes, but luckily, thousands of people were safely evacuated, so it wasn't as bad as it could have been. In the past, scientists were worried that a huge eruption could cause the entire western side of the volcano to break off and crash into the ocean. This could create a mega tsunami, sending massive waves hundreds of feet high across the Atlantic Ocean. But more recent studies have shown that this is very unlikely to happen. Mount St. Helens is a volcano in Washington State in the United States. It had a massive eruption in May 1980 that ended the lives of 57 people. That eruption also caused the biggest landslide ever recorded. Hot, pressurized magma exploded from the volcano, shooting ash 15 miles into the sky. Ash covered a huge area, and around 230 square miles of land was destroyed. Mount St. Helens is still active and is expected to erupt again someday, possibly even in our lifetimes. But experts say it's not likely to have another huge sideways blast like the one in 1980, thanks to a deep crater that is now formed at the top. it will change the way the volcano might erupt. Popocatépetl is a big, active volcano in Mexico. It's been slowly erupting on and off since the early 2000s. It's really close to a lot of people, just 40 miles from the Mexico City metropolitan area, which has about 22 million people, and 30 miles from Puebla, which is home to about 6 million inhabitants. If Popocatépetl had a huge eruption, it could cover Mexico City in thick ash as much as 8 inches deep. That ash could block drains, mess up the water, and even stop the electricity from working. Even worse, fast-moving lava and super hot flows, called pyroclastic flows, could rush down the mountain and destroy towns nearby. The volcano was quiet for 50 years, but now it rumbles and shakes pretty often. There have been over a dozen small eruptions, including some as recent as February 2024. Some nearby places got covered in ash, but scientists say this isn't too surprising, and they're keeping a close eye on it. Frankenstein, unreasonably cold weather, and tons of lava. What do these things have in common? They all trace their origins back to Mount Tambora. This volcano in Indonesia had such a massive impact that the aftermath could be felt in Switzerland even a year later, and these spots are thousands of miles apart. Soon, we might be facing something similar again. Stick around, because I'm about to reveal the exact spot where the next eruption is expected to happen in 2025. Back in 1815, Mount Tambora erupted with unprecedented force, sending a colossal cloud of fine particles into the atmosphere. This cloud reflected sunlight, leading to global cooling and even the year without a summer in 1816. Temperatures plummeted, crops failed, and families worldwide faced food shortages, compounded by various health issues. Fun fact: Frankenstein appeared because of abnormally cold weather in the summer of 1816. The author got stuck indoors in Switzerland and wrote this story to pass the time. But that is the only positive aftermath. In England and Ireland, people struggled to find food. The crops were too bad that year, and this year without summer cost them lives, all because of the eruption in Indonesia. While many other volcanoes have erupted since then, none have had consequences as dramatic as Tambora. However, climate professor Marcus Stoffel from the University of Geneva believes potential serious eruptions aren't just a matter of luck, it's only a matter of time. So it's up to us. We can sit back and wait for the inevitable, or we can start preparing today. This future eruption will happen in a world that's vastly different from the one in 1815. Not only is our planet more densely populated now, but we've also experienced irreversible changes that affect our daily lives. Now, if you think volcanoes are always the bad guys, think again. They've actually played a crucial role in shaping our planet. They help with land formation, atmospheric development, and climate modulation. Just look at Yellowstone, for example. When thick lava oozed to the surface, it spread across the landscape and transformed the area forever. When volcanoes blow their tops, they release a mix of lava, ash, and gases, including carbon dioxide. But don't worry, compared to the emissions from fossil fuels, the amount from volcanoes is pretty tiny. What scientists are really keeping an eye on is sulfur dioxide, because it can have a big impact on our climate. When a major volcanic eruption happens, it can send sulfur dioxide soaring into the stratosphere, which is about 7 miles up in the atmosphere. Once there, it transforms into tiny aerosol particles that scatter sunlight, helping to cool the planet. This cooling effect isn't immediate though. Those particles can hang around for a couple of years and even circulate all around the globe. Nowadays, we've got special equipment to monitor sulfur dioxide emissions from space. Take Mount Pinatubo in the Philippines. During its eruption in 1991, it released around 15 million tons of sulfur dioxide. Now, while that's a lot, it wasn't quite as massive as the eruption of Tambora. Still, Pinatubo managed to lower global temperatures by about 0.5 degrees Celsius for several years. Tambora, on the other hand, dropped average global temperatures by about 1 degree Fahrenheit. I know what you might be thinking. That's not much, but trust me, it makes a difference. If the planet warms up by just 1 degree Fahrenheit, it could really mess with sea levels. Experts think we might see a rise of up to 8 inches by the end of this century. This could wipe out a lot of farmland and coastal habitats, which would be a huge blow to many communities. So maybe a volcano eruption that can cool off the planet is like a natural mechanism helping us out? Not exactly. While it does cool the planet off, don't get tricked into thinking it's the kind of coolness our planet needs. Such temperature shifts can severely mess up with the crops, like they did in 1816. There's also evidence that major eruptions can disrupt rainfall patterns, leading to drier conditions in monsoon regions across Africa and Asia. You see, the summer monsoon relies on the temperature difference between land and ocean, which can be altered by volcanic activity. Interestingly, a warmer climate may enhance the cooling effects of volcanic eruptions. Experts explain that the formation and movement of aerosol particles depend on climate conditions. As global temperatures rise, faster air circulation can lead to smaller aerosol particles, which are more effective at scattering sunlight and thereby intensifying the cooling effect. Oceans also contribute to this dynamic. A warming ocean surface creates a stratified layer, hindering the mixing of warm and cold water, which could mean that volcanic eruptions primarily cool the upper ocean layer and the atmosphere above it, according to Stoffel. Moreover, climate change may influence volcanic systems directly. The melting of ice can trigger more eruptions by reducing the pressure that allows magma to ascend more easily. Additionally, increased rainfall associated with climate change can seep into the ground and interact with magma, potentially sparking eruptions. While the prospect of a cooling period due to a volcanic eruption might seem beneficial amid climate change, scientists warn that the effects could be dire. The immediate consequences could be severe, particularly for the estimated 800 million individuals residing near active volcanoes. A major eruption could devastate entire cities. For example, Campi Flegrei, located near Naples, Italy, is showing signs of increased activity and threatens the lives of about 1 million people. Now, if you're from Oregon, beware, as experts say this state might experience volcano eruptions. Are you scared? Don't be. It's actually not as scary as it seems. Let me explain why. There are more than 80 volcanoes in Oregon, but we're not interested in a single one of them because it's an underwater volcano that is likely to erupt in 2025. Axial Seamount is the most active volcano in the Pacific Northwest, yet it remains largely unknown to the public due to its location approximately 300 miles offshore and nearly a mile beneath the ocean surface. While its upcoming eruption is expected to pose no threat of a tsunami or significant land-based earthquakes because of its depth and distance from the Cascadia Fault, the data gathered from studying its eruptions can enhance our monitoring of potentially more hazardous volcanoes. Let's call it a friendly eruption, shall we? In reality, predicting eruptions is a complex endeavor. We often encounter alarming headlines, such as, "Yellowstone is about to erupt." Should we take these claims seriously? Not really. Yes, Yellowstone sits atop an active supervolcano that has experienced 3 major explosive eruptions in the past 2.1 million years. The last eruption occurred approximately 70,000 years ago, with the most significant explosion taking place around 631,000 years ago, forming the massive Yellowstone caldera. Naturally, many people are curious about whether Yellowstone will erupt again and when that might happen. Fortunately, scientists are employing new techniques to delve into these questions. A recent study suggests that Yellowstone is unlikely to experience another major eruption anytime soon. The reason is that the magma beneath the park is divided into a network of separate chambers. While there is a substantial amount of magma present, it's not sufficiently interconnected to support an eruption. Previous studies proposed that the existence of a massive layer of magma beneath Yellowstone, but these latest findings change that notion. To gain a clearer understanding of the subterranean dynamics, researchers utilized a technique called magnetotellurics, which employs Earth's natural electromagnetic fields rather than seismic waves. Since magma is a good conductor of electricity, this method is particularly effective for mapping molten rock and comprehending underground activity in volcanically active regions. By using magnetotellurics, scientists created a detailed map of the magma under Yellowstone, enabling them to make more informed predictions about future eruptions. But what will happen if an eruption similar to Mount Tambora occurs? By and large, there will be huge climate chaos. Yeah, the best scientists are looking for the solution should it really happen, but they don't have it yet. So technically, we're not ready for the second Mount Tambora. But for now, we're pretty much safe. No major eruptions are predicted. Whew!
Oh boy, scientists predict a volcanic eruption that is likely to be one of the most destructive in the history of our species. There's a 1 in 6 chance of it happening in this century, and it could seriously change the climate even more and put millions of lives in danger. Back in January 2022, the Hunga Tonga Hunga Ha'apai volcano erupted in the South Pacific Ocean, creating a huge explosion. It sent tsunamis all the way to Japan, North America, and South America. Tonga itself was hit hard, with damage costing nearly 20% of the country's entire economy. Now, researchers at the Niels Bohr Institute in Copenhagen have studied ice samples from Greenland and Antarctica, and their findings are worrying, predicting potential global volcanic disaster. They say there's a real chance of a much bigger eruption, a whopping 10 to 100 times larger than Tonga's. In the past, eruptions this size used to change the climate and even cause civilizations to collapse. Despite future volcanic eruption risks, experts say the world isn't prepared at all. Michael Cassidy, a volcanologist from the University of Birmingham, warns that no sufficient effort is made to handle a disaster like this. He says that NASA and other space agencies spend billions on asteroid defense. At the same time, a volcanic supereruption is way more likely than an asteroid impact. And right now, there's no global plan for dealing with a massive eruption, even though it's likely to be far more destructive. The last magnitude 7 eruption happened in 1815 at Mount Tambora in Indonesia. Then, thousands of people lost their lives in just a few days. The disaster also disrupted weather and caused food shortages worldwide, affecting millions. That eruption was the biggest in recorded history. It blasted a massive cloud of particles into the sky. Those particles blocked sunlight, cooled the planet, and caused worldwide chaos. The year after the eruption became known as the Year Without a Summer. Temperatures plummeted, crops failed, famine spread, and a cholera pandemic broke out, leading to tens of thousands of lost lives. A shocking fact, the eruption may have even inspired Mary Shelley to write Frankenstein while stuck indoors during the unusually cold summer of 1816 in Switzerland. Now, since then, many volcanoes have erupted, but none have matched Tambora's scale. Now, over 200 years later, scientists warn that there's a new supervolcano threat. Another massive eruption could be on the way, and the world might not be ready for it. So, while scientists seriously discuss the likelihood of the next volcanic eruption, experts are calling for urgent action to prepare before it's too late. So, the thing is, a massive volcanic eruption today could be even more devastating than the Year Without a Summer. Unlike back then, we're already dealing with all kinds of weather changes and a more fragile global system, which could make the effects even worse. Dr. Michael Rampino, a geological scientist, warns that the world is more unstable now, and it means that a modern-day mega-eruption could have even more severe consequences. But this time, greenhouse gases from fossil fuels may make the aftermath of such an eruption even colder instead of warmer. So we're talking about volcanic activity endangering humanity. Dr. Thomas Aubrey, a volcanologist, found that in a hotter, more turbulent atmosphere, the sulfur dioxide gas released by a volcanic eruption would spread faster and farther than in the past. This gas forms sulfate aerosols, which reflect sunlight and cause global cooling. Because these tiny particles would be more evenly distributed, they'd have a stronger cooling effect than in 1815. Another atmospheric scientist at Cambridge explains that the size of these airborne particles matters. It affects how they absorb sunlight, and in a future warmer climate, an eruption could make the surface cooling stronger by 15%. At the same time, there are still many unknowns. Scientists from the University of Geneva say that we're only beginning to understand the full impacts of such an event. It's also difficult to precisely estimate future volcanic eruption risks, since we have very little data on older eruptions. So, to understand past volcanic activity, researchers analyze ice cores from Greenland and Antarctica, as well as ancient tree rings. Those act as historical records of weather changes. These measurements suggest that several eruptions in the past few thousand years temporarily cooled the planet by about 2 to 2.5 degrees Fahrenheit. One of the most catastrophic examples is the 1257 tsunamis eruption in Indonesia, which was so powerful that it likely triggered the Little Ice Age. It was a period of global cooling that lasted for hundreds of years. More recently, the 1991 Mount Pinatubo eruption in the Philippines slightly cooled Earth for a few years. Because this eruption happened in the satellite era, scientists were able to measure exactly how much sulfur dioxide was released and how it affected the atmosphere. But even with modern tools like satellites and seismic instruments, scientists still have difficult times forecasting the next big volcanic eruption. Luckily, even though we can't predict the exact timing, we can study worst-case scenarios to help authorities prepare. This includes creating evacuation plans and stockpiling food in case of global crop failures caused by volcanic cooling. The changes in weather patterns might make volcanoes more active. Melting glaciers can reduce pressure on underground magma, which will increase the chances of an eruption. Plus, more extreme rainfall, which is becoming more and more common, can seep into volcanic cracks and cause powerful steam-driven explosions. It can affect both active and dormant volcanoes. Because of these risks, researchers are now mapping volcanoes that are the most vulnerable to climate change. Their studies show that the highest supervolcano threat comes from such areas as Iceland, Chile, and Indonesia. Those are places where glaciers are melting quickly or rainfall is increasing dramatically. A 2022 study found that 716 volcanoes worldwide, that's about 58% of all known active above-ground volcanoes, could be triggered by extreme rainfall, increasing the likelihood of another mini ice age. Now let's get back to that Hunga Tonga Hunga Ha'apai eruption that occurred on January 15, 2022. Scientists have confirmed that it created the highest plume ever recorded. The volcano, located underwater in the South Pacific, sent an ash cloud 187,000 feet high. That's higher than any previously recorded eruption. What makes this eruption even more remarkable is that it was the first to ever reach the mesosphere. It's the third layer of Earth's atmosphere. The mesosphere begins at about 160,000 feet above Earth, where meteors start burning up and creating shooting stars. To measure the plume's height, researchers from the University of Oxford and RAL Space used data from 3 geostationary weather satellites. Before this, the record for the highest volcanic plume was held by Mount Pinatubo's 1991 eruption in the Philippines, which reached 131,000 feet high. Interestingly, this kind of measurement was only possible thanks to modern satellite technology, and a decade ago, no one would have been able to do this. Another volcano we should mention in relation to a potential global volcanic disaster is located on Iceland's Reykjanes Peninsula. Its latest eruption happened in November of 2024, leading to evacuations in nearby areas. The eruption began just after 11 p.m. with little warning. The volcano released orange lava from a nearly 2-mile-long fissure. Authorities ordered evacuations for about 50 homes and guests staying at the Blue Lagoon Spa Resort, a popular tourist destination southwest of Reykjavik. While air travel was not affected, officials still warned of potentially dangerous gas emissions spreading across parts of the peninsula, including the nearby town of Grindavik. Grindavik, home to 3,800 residents, has repeatedly witnessed volcanic activity, and past eruptions even damaged its infrastructure and forced evacuations. For example, in August 2024, a 2.5-mile-long crack opened at the Sunthunkangigar crater near Grindavik. It led authorities declaring a state of emergency as lava flowed in multiple directions. Fortunately, Iceland's meteorological office reported that the latest eruption was significantly smaller than the one in August. Geophysics experts conducted aerial surveys and figured out that the situation appeared less intense than the previous eruptions. These days, Grindavik is not at risk, but the possibility of further developments cannot be ruled out. Scientists predict more volcanic eruptions.
The ground suddenly starts shaking. Clouds of gas start forming in the sky, making it dark during broad daylight. Bits of the ground start swelling, lifting, and even collapsing. These are the telltale signs of a volcano that is bound to erupt. And this is what could easily happen again with Mount Spur. It's only about 75 miles from Anchorage, one of Alaska's busiest cities. More than half of the population of the northernmost state of the US live there. There's also a huge amount of air cargo that passes through its international airport daily. So anytime a volcano this close to such a vital hub begins to get restless, people start paying attention. Just FYI, approximately 350 million people in the world live within the danger range of an active volcano. That means that around 1 out of 20 people live in an area at risk of volcanic activity. Alaskans probably wish that Spur's reawakening was fiction, but it's actually true. The Alaska Volcano Observatory picked up on several of these "I'm about to erupt" signs from Mount Spur. So much so that they raised the alert level to yellow, which means unrest above normal background levels. Spur erupted twice in the 90s, and it was pretty intense. If we were ranking volcanic eruptions on a scale from 1 to 10, these eruptions would rank a 6 or 7. Not that terrible, but still worth 10 to 17 million in damages. However, these numbers are nothing compared to Alaska's 1988 Redoubt eruption, another volcano that erupted and summed up a staggering $345 million in damages. Mainly because its ashes hit aircraft engines, such as the KLM 747 that lost power after all its engines went off due to the ashes. If people weren't paying attention to Alaska's unstable geology before that, well, they surely started to after it. When you think of the hazards of volcanic activity, the first thing that might possibly pop in your mind is Pompeii, Italy. Of course, that's the worst-case scenario, a city being engulfed by lava. Spur may seem innocent compared to Vesuvio, but it still took its toll. The last time it erupted in the 90s, and it threw volcanic aerosols over 60,000 feet into the atmosphere. Let's get our science straight here. Think of volcanic aerosols like liquid particles that are released into the atmosphere during an eruption. These particles are usually created when gases from a volcano, such as sulfur dioxide, combine with water and other particles that exist in our atmosphere. These aerosols can actually cool the Earth's surface since they reflect sunlight directly back into space. And that's not the worst part. It can stay in the atmosphere for several years after an eruption, causing lots of health issues. The eruption unleashed blazing fast avalanches of hot gas and ash called pyroclastic flows, along with thick, muddy floods known as lahars. Oh, and there were also the massive volcanic boulders. These rock chunks were huge, some over 3 feet long, and they blasted out from the volcano like nature's cannonballs, landing more than 6 miles away. All that volcanic heat melted part of a nearby glacier, kicking off debris flows that dammed up the Chakachatna River and created a whole new lake along the valley. Some good came out of Spur's first eruption, though. The main lesson was, volcanic monitoring pays off. The local monitoring was able to reduce the economic damage done by the eruption, especially for a city that has an intense air traffic. Spur is deemed as dormant for the moment, but it could go off anytime soon. You see, volcanoes are classified as active, dormant, or extinct, depending on how much action they're putting on. If it's still active, it's still rumbling and erupting somewhat regularly. Dormant means it's had some recent activity, but it's still lying low for now. And extinct, that's when it's been quiet for such a long time that we figure it's done for good. One of the US's most dangerous active volcanoes is Mount St. Helens. This volcano is actually responsible for the most powerful eruption in US history. Its last blast was so intense, it threw off about 1,300 feet off its summit. Basically, the top of the mountain vanished, and if you thought Mount Spur's ash cloud was impressive, St. Helens wins the competition since it launched its ashes 80,000 feet into the sky. Eastern Washington plunged into total darkness. But it wasn't just that. In a matter of 3 minutes, the eruption hurled 3.7 billion cubic yards of blazing rock and dust, enough to fill 1 million Olympic-sized pools across 230 square miles of lush forest. Actually, the earthquakes that anticipated the eruption started weeks before May 18, 1980. A ground shake of magnitude 5.0 went off, triggering a landslide on one side of the volcano. By the end of the official eruption date, 57 people had lost their lives. Nearly 7,000 big-game animals like deer and elk were wiped out, and millions of birds laid scattered on the burnt earth. Researchers don't think St. Helens will blow at the same magnitude again anytime soon, but they're keeping an eye on it, because this volcano is not exactly finished. By the way, the word volcano comes from the Roman name Vulcan, which was the Roman deity of fire, and they often happen at the meeting point of tectonic plates, which are the pieces of the Earth's surface that fit together like a jigsaw puzzle. The so-called Ring of Fire, located in the Pacific Ocean, is the world's danger zone when it comes to volcanoes. It contains between 750 and 915 active volcanoes. The largest volcano located in the Ring of Fire, also the largest active volcano in the world, is the Mauna Loa. It's over 13,000 feet high, and it's located in Hawaii. Researchers say that Mauna Loa has been erupting for at least 700,000 years. Its most recent eruption began on the 27th of November 2022, and it lasted until December 13th. It's been quiet since the 80s until it decided to wake up again. Thanks to constant monitoring by the Hawaiian Volcano Observatory, it didn't cause any casualties when it last erupted. Scientists have been investing big time on volcanic monitoring, not only to reduce economic hazards, but also to save lives. The most recent attempt has been to drill into volcanoes. Recently, a group of scientists went all the way to Iceland in one of the world's volcanic hotspots. There are around 33 active volcanoes in Iceland alone, but the one that is the most interesting to them the most is the Krafla volcano. The Krafla has erupted around 30 times in the last 1,000 years, and its most recent eruption was in the mid-1980s. The project named Krafla Magma Testbed, or KMT for short, is hoping to advance the understanding of how magma behaves underground. The main advantage of this drilling research is predicting the risk of eruptions, but it can also help to push geothermal energy forward. I mean, can you imagine having electricity that is run by the limitless source of volcano power? The KMT team will begin drilling holes deep into volcanic ground in 2027. They're aiming at reaching over a mile into the ground. After all, it's different to monitor lava activity when it's on the surface than when it is still below ground. This will allow researchers to listen to the pulse of the Earth, according to them. They're saying this research is as revolutionary as the first time man went to the moon. Oh, and speaking of that, I was shocked to discover that volcanoes exist all throughout the solar system. Yep, other planets and moons have volcanoes too. The largest volcano in our solar system is Olympus Mons on Mars. It's a shield volcano, much like the ones that make up the Hawaiian Islands. It's about 370 miles wide. If we transported it all the way back to Earth, it would almost occupy all of Poland. Yikes.
Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, you'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a super eruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campi Flegrei, and it's actually one of the largest volcanoes in Europe, sitting under the town of Pasquale. So, Campi Flegrei erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campi Flegrei has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campi Flegrei is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980, and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news, because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rock it spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817 as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami, with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of super eruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 super eruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a super eruption. In Bolivia, the Juturancu volcano is also acting up. It's part of a group of volcanoes that have caused super eruptions in the past. Since the 1960s, the ground around Juturancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a super eruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a super eruption could happen sometime in the future, and when it does, we'll need to be prepared.